Hi again, it's Krish. In this time, I'm gonna explain another method you can apply on inequality coefficients that includes modulus parts in it, but not for all inequality coefficients. There are some special circumstances and requirements needs to be satisfied by the coefficients where we gonna use this method. And why this method is so important is that does not take long time period other methods take, and if you have the right correction that we can use this method, then you can save your time at the exam. And the only thing you need to know is some basic rule regarding the theories of inequalities. And I will explain this everything. Yeah, let's go to watch this video. If you can notice the signs of values on left side and right side in an inequality, let's say +5 is greater than +3, at that time you can add any of indexes up out of these brackets. If you want, you can add 3. If you want, you can add 2. It means you can make each side a square. That does not affect to the main inequality. Even here you can get the final inequality as 25 is greater than 9. This is a right inequality, but unless if you have at least one negative sign for one side, let's say -3 is less than +2, here you can notice you have one negative sign. At the time you are not allowed to do this simplification. Let's imagine that we are doing this simplification and we make each side a square. Let's see what is the results we can get. Here we can have +9 and here we can have 4. There's no rules, we need to change this sign, and this is the final inequality we got. So 9 is not less than 4. We got an incorrect result because we did something wrong at the beginning. So that's why we got this wrong result. So this is what I mentioned that we're gonna use on the inequalities that includes modulus. So I think this is a kind of basic rule regarding the inequalities. So let's see how we can apply this. For a second, I can remind what is the meaning of this modulus. If you consider the modulus of -3, it gives always positive value, +3, not for the 3. Whatever the value you put inside this modulus, whether it's negative or positive, that final value coming out should be a positive result. That is what this modulus meant. So if you put +4, there's nothing you need to change. It's +4 the result. And if you consider the modulus of -5, what's the value it gives is +5. That is what this modulus meant. So it means we can make sure that each side on this inequality is positive here. Even this one positive and this one positive, because at the time we have this modulus, that means final value is a positive value. So we can make each side square here. We can do this simplification. So as we know the theories of not inequalities, of modulus, we are allowed to square any of modulus, then it gives a result without modulus here. So it means that we don't need to add modulus. We can consider the square of the expression inside this modulus. So then we don't need to write this modulus signs here. Then we can consider x -1 into the power 2 and greater than x +3 into the power 2. Then this is a kind of basic inequality coefficient that does not have any modulus. So then we can get this one to the right, not left. So then we can see a difference of squares. Then we can write that simplification behind the difference of 2 is cos a minus b, a plus b. So what is the last simplified expression we can have here? Minus x plus x, then each x got cancelled. Minus 1, minus 3, minus 4, and x plus x is 2x minus 1 plus 3 is plus 2. Then we can divide both sides by minus 4. We know that we have to change the sign of inequality if we are dividing by negative terms. Then 2x plus 2, if you want you can divide both sides by 2. Then this is the last inequality. We got x plus 1 is less than 0. Then we can isolate x on the left side. So this is the range of x that satisfies the inequality we got here. That's how you can apply this simple theory regarding the inequalities.